What is up, everyone? Moving on from the fundamental counting principle into permutations. So I will say that permutations, you can use the fundamental counting principle a lot of the time. All right, but there's going to be a couple little different things. There's going to be a formula. We're going to use that factorial button. Again, I will try to post a video of where to find the factorial button, but worst case scenario, you can just kind of multiply it out using a calculator. So, permutation. A permutation still is finding the total number of possible outcomes. However, permutation is a very specific thing, and that is the order matters. So when you think of order, all right, so say we have 5 cards, right? So say we have two of hearts, 3 hearts, 4 hearts, 5 hearts, 6 hearts. Now, if we put them in order from least to greatest, that is order, right? Like the order matters. But if you're playing a hand of cards and you get them dealt to you, it doesn't matter what order they were dealt to you in, they're still in your hand. So the order that they're dealt in doesn't matter because it's just a hand of cards. But if I was trying to get a straight, then the order of the cards that I have does matter. Hopefully that makes sense. So let's think about some things where order matters. All right. So the first thing is like a lock combo, right? So when you're making a combination of a lock, if you put the order in incorrectly, the lock's not going to open. So the order matters. Also, we have passwords. Okay, so obviously a password, very similar to a lock combo. The order that you put the letters in matters. Okay. The order of people finishing in a race. First place is different than third place. So again, order matters. So one of the things you're going to have to consider after next week's lesson on combination, or one of the things you have to think about is, what type of problem am I dealing with? Is it a problem where the order matters, like the examples we just said, or is it a problem where order doesn't matter? And I'll kind of help you understand the differences as we go through them. So back to permutation. So permutation, order matters. Now there's 2 types of permutations. The first type is without repetition. So once you get picked once, you can't get picked again. The second one is with repetition. So again, that's kind of think back to the fundamental counting principle license plate that we did, right? So, or with the lock combination. So sometimes repetition's allowed, sometimes it's not. So again, you have permutation and combination. Combination we're going to do next week. Then you have underneath those, you have permutation without repetition and permutation with repetition. And as I was saying, we still can use the dash method. Most of the time I usually prefer the dash method to the formula I'm going to show you. But it really is going to be up to you on how you want to do it. And I'll do them both ways just so you see them. Now, the permutation formula. Now there's 2 formulas. There's one for without repetition and one with repetition. With repetition, the formula is n to the r. And I'll explain what n and r here are in a second. Without repetition, it's n factorial over n minus r factorial. So remember, factorial means whatever that number is. So like say 5. 5 factorial is shorthand for 5 times 4 times 3 times 2 times 1. All right, so that's what factorial means. If it was 10 factorial, it would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Again, that's why sometimes it's going to be nice to have the factorial button. All right. So, what does n and r mean? So, these definitions are going to be very similar to the dash method. So N represents the number of items to choose from, and R is the number of times you are choosing. Okay? So if you think back to our dash method, the dashes was the number of times we're choosing. What you fill into the dash is the number of items to choose from for that specific choice. It'll make more sense once we start looking at problems. So let's look at this first one. So it says 20 kids in a class. How many ways can the 20 kids be? There be one president, one vice president, and one secretary. So what does that mean? Out of all the 20 kids, any one of them could be president. Okay, but once that person's president, they can't be vice president anymore. Once the person's a vice president, they can't be the secretary. So everybody has equal odds of being any of those three things, but the odds change when you pick one person to be president. So let's just say we're going to pick the president first. Now, if we were using the dash method, we have to pick 3 offices. That means we are choosing 3 times. President, vice president, secretary. Now, if there's 20 kids in the class and we're trying to pick a president, that means we have 20 options to choose from. But once we pick that person for president, they cannot also be vice president. So this is a problem without repetition. Very important to understand. So this is without repetition. So then now, how many kids do we have left to pick from? 19. So we have 19 students left. After I pick the vice president, I only have 18 students left. So I can do 20 times 19 times 18. So again, this is how we can use FCP within a permutation. So that gives us 6,840. So that means there are 6,840 different ways that we can have a vice president, a secretary, and a president, and all 3 are different from the previous option. Now, let's think of this as using the permutation formula. So we're going to be using this one here because that's our formula for without repetition. So N, again, is the number of items to choose from. So we have 20 students to choose from, and R is 3 because R is the number of times you are choosing. So if we're using our formula, that would be 20 factorial over 20 minus 3 factorial. Now you simplify what's in the parentheses first. So I'm going to go 20 factorial over 17, because that's going to be 20 minus 3 is 17, 17 factorial. Now before we simplify this, I want to show you something. Let's say you had 5 factorial over 3 factorial. Now remember, 5 is 5, 4, 3, 2, 1. 3 factorial will be 3, 2, 1. With multiplication, we can reduce these out before we multiply them. So that means whatever is in the denominator, if that same thing is in the numerator, I can cross those off. So 3, 2, 1 goes away in the bottom, 3, 2, 1 goes away. So 5 factorial divided by 3 factorial is just 5 times 4. Taking that concept over to here. Remember, 20 factorial is 20 all the way down to 1. 17 factorial is 17 all the way down to 1. So what we can do is get rid of the 17 to 1 in the numerator. And then that means the denominator goes away as well. So in our numerator, we're only left with 20 times 19 times 18 because the 17 down to 1 got reduced because we had that in our denominator. And if you look back at our FCP, that's the exact same thing we did. So again, formula or fundamental counting principle, you're going to be doing the same thing either way. Check out video number 2.